What's up, guys? Welcome back to the channel. We're back here at the Black Gold Barndominium. It's always exciting to be over here and to put on display for you guys, showing you all of the special details that we've been able to do and what we're achieving on this project. Now we're actually here to do some performance testing today on this build, and I'll tell you guys a little bit more about it here in just a bit. But today we're going to be talking about showing you some of our Monopoly framing, the way that turned out on this structure, as well as showing you some of the finished progress that we've got so far up to this point. For those of you that have been following along on this channel, you know that we strive to have air tightness and to achieve better performances and to try to come up with ways to maybe streamline better efficiencies that we can pass on to our clients. Today, this build, I feel like, really has a large example of that. We're making a lot of progress as well with the build. So I hope you guys enjoy this video. Let's get it going. We're pretty pumped about this because what we've been able to do is this is the first time we've ever built a steel hybrid frame barndominium where we did the zip system as a complete air barrier on the whole project. That's right, our steel frame, everything is under our zip system and it's all covered. And we also have the R sheathing as well on the walls on this build. But the roof has been raised up with our sleeper studs and the zip sheathing. So today what we're going to do is we're going to put all this under test. We're going to do a blower door test, which is basically creating negative pressure on the interior by using a fan at the door to remove a lot of the air that's on the inside. And what that will do is tell you how much air you might be losing through windows, doors, or any penetrations throughout the house. All right, right now, Justin is sealing off the door with the blower door components. And as you'll see, he'll start putting all the fan and all that stuff here in this once he gets it all sealed up into this door. We're actually using one of the standard doors on the back of the house because all the other sliding doors will just be able to easily be shut. Essentially what's happening here is they're creating negative pressure that would be essentially like bringing 20 miles per hour of wind to the exterior of the home. Mainly letting you know what type of leakage is coming maybe through any windows or doors throughout. So it's a negative pressure that's going to be happening on the inside. Ultimately, the goal is that we could find leaks if there were some, because we'd be able to hear those and be able to feel them as well. So if we're not getting the results we want, we can go around and start looking and see what kind of holes we find. So that would be part of this test as well, and another good reason why you would do a blower door test this early in the process. So I was asking Justin earlier, like what kind of, he does this all the time, so what kind of score he thinks I'm going to get. What do you think?
I believe if everything's tightened up, if there's no penetrations, I think you'd be under code.
Under code?
Yes, sir.
Okay, what is code?
3 or under.
Yeah.
Depending on what county you're in, what zone.
Yeah.
Energy Star rated, you know.
Yeah. And as a reference, we did this before. We did a blower door test on a finished project that we did in North Lake, Texas. It was a 1.303 score, I think we got, right? On that one. I was thinking it would be like a 3.
I'm gonna shoot for under 3.
Under 3.
Yes, sir.
So there you go. The goal obviously would be under code, which Justin's giving us a vote of confidence because you think we're pretty tight.
I think it looks tight.
Looks tight. Hey, that's results so far.
We're gonna be under 1 air change per hour.
Yeah.
That's what I'm saying.
Oh yeah, guys, getting ready to turn the fan on. Justin's got a module that is going to read measurements to us. Tell us what you're going to do, Justin. You're going to tune it up to what?
We're gonna turn it to 50 CFM.
Yeah.
And then our reference number will show up, and then we'll take the square footage and the volume. We'll times it by 60 and see where it is.
And on this one, we have that square footage that Brandon told us a while ago. So we'll get the reference number, divide it by the volume, and then times it times 60.
Yes.
Okay, see, I've never done this before, and look at it. Like, I got this down.
Here's the deal. Look, it's so low that it's not even, it's so tight, it's not even
doing anything yet.
It's not even engaging the rear.
So right now, it's so tight, you're not getting any air.
Wow.
You can hear it?
That's crazy.
It's
Do we
depressurized.
need to open a door?
Wow.
It says it's so tight, he's not even getting any pressure. It says low.
It says low. So our number is to reach it to 50 and see where we're getting our reference number, but it's not even registered because it's so tight. All right, circle back.
Yeah.
Let me put another ring on it.
Okay.
Wow.
All right, well, we're getting ready to run the fan. Justin's got everything sealed off. Basically, what we're going to be looking for is we're going to get CFM, a reference number, divided by our volume, which in this case is like 93,500 cubic volume. And then that number is going to be multiplied by 60, which is the air changes per hour based on 60 minutes. So let's fire it up. So what kind of pressure are we going to?
50.
50, okay. Okay, so you're getting it dialed down here. Tell us what we're looking at here.
Okay, so this is our reference number. We have 1,777. So what we're going to do is we're going to take 1,077 divided by the
93,500
93,520 times 60, which leaves us 0.69.
0.69 for a score on this. So what do you think is a pretty decent score?
That is incredible. That's beyond decent.
Beyond decent.
Beyond decent. That's incredible.
It's pretty darn close to passive ratings as well when you get to that score, because we're under a 1, which the code requirements are like 3 and higher at this stage, depending on counties and zones. And wow, so I'm pretty excited about that. At this stage, should we maybe run it and see if we can find some?
Yeah, we can walk
it out.
Exterior walls and see if we can pinpoint where the penetrations, where the
All
air's
right.
going through.
Let's see. The door was open.
Oh, that's crazy.
Here
Oh,
too.
you know why? Look at this.
Oh, the seal.
Yeah, the seal.
So you could hear the door was not shut all the way. You could hear a whistle. It's because the door wasn't shut all the way. And also another thing, you can see the strip at the bottom is out on this particular door. I think we might have lost a little bit. Maybe we have to retest. Got to get a better score. Another door that wasn't shut all the way. Well, we do have a lot of doors on this build, so. So what kind of pressure are we putting on all this? We got, you said 20 miles per hour?
Miles per hour, man.
Let's see what we got over here. We did have a few penetrations over here, so all that's did get sealed off.
We're losing air right here. Still right here.
Feel it somewhere. Where am I feeling it?
I feel it right
I
here.
feel it right here, but I don't know where it's coming from.
It's not here.
Right there. Right there. I feel a little bit right there. I want to show you this, how precise you can be, because you can feel this little bitty air. Well, this is just a spot where the caulk gun had a misfire, and you can see the gap right there. And you can feel just a slight little bit of air right there. Those are something that's causing performance failure. I mean, I don't know if you can say failure, but it's something that you could be that precise with by doing a performance test.
Absolutely. Absolutely.
Some of this is we're getting better performance right now at this stage than we did on a completed home that had all the drywall and everything, insulation, spray foam. This is already getting a better score than our North Lake build. And it's primarily due to the fact that we have the zip sheathing on the outside, on the roof, as well as the walls. But our monopoly framing, the way that we're doing it, where we're taking everything to the edge and sealing all of it off, giving us a tremendous advantage for air tightness.
Just checking around for leaks. I'm marking areas where we got leaky walls so we can come back later and seal them up.
Yeah, I feel a little air here. We got one hole here, one hole here. Look, you can feel the air. Brandon! We need some caulking. All right, well, we took a minute to go and explore and to find maybe potential leaks or leaks, actual leaks. And we were able to find a few things, a few doors that were not shut all the way. So now we're gonna run the test again, see if we get any better. So, and that's what this is about. It's about exploration to determine on performance if you can make improvements on the spot. But now we're gonna run it one more time. So Justin. 60, so we're trying to get it now 54, 56, 52, right, close. So right at 50, he's got 944 CFM, so he's gonna take that, he's going to divide it by our volume, which is 93,520, and then he's gonna multiply that by the 60, which is the per hour change is what? What do we got?
0.60.
0.60. There you go. A little better than a 3, isn't it?
At a free drywall page. That is unbelievable.
It's incredible. That's exciting, man. I'm just so excited you guys came out because this is really giving us an idea of performance at this level. Now we're gonna come back, we're gonna do another test once we get a little further down the road as we're able to address some of these issues as well. But man, Justin, appreciate it, man.
That was a learning experience.
Yeah, thank you. So guys, you can be airtight with the zip system. Like this is it. We are 0.60. It's amazing. It's the best score we've ever got because we're doing some of these methods where we're going over top of our hybrid steel frame, and there's a lot, I think, even better we can do as we improve some of these methods. In the meanwhile, we'll be back showing you guys more progress on this build. One of the major things that we've been able to do while we've been out here is get all of our doors and windows installed. I wanted to explain to you guys how our overhangs are working on this deal because that's the monopoly framing. Monopoly framing is essentially taking like your walls and your deck on the roof and meeting those together so you can get a tight seal, and then your overhangs usually get applied after the fact. Well, this is how we're doing it on this build. We've got our walls that go up here, they go all the way up to the top, and you can see the overhang, how it's suspended out there. Now we do have these joints which hold the purlins into place for the overhangs. Over these areas, these are not going to be conditioned areas. There's not going to be any openings here, so air is not going to be coming through. But what we were able to do is to fabricate like a flange system where we could attach these purlins directly to the outside. And because you can span a purlin 20 to 30 foot, we're able to do that and only have a fastener every 20 to 30 foot, which makes it really nice here. As you can see, we've got a seamless connection up at the top. We feel like that for us, with the steel buildings, we're able to achieve some of these things that maybe in a wood frame application alone, you wouldn't easily be able to accomplish. But because we're kind of used to doing it, it made it easy for us to adapt to doing some monopoly framing on this particular build. One thing that you guys might not have seen in the last episode, because I don't think it was done yet, you can see I got this decorative gable that comes out over the front porch entry. Now this was a little bit more of a challenging spot for us because we had the zip going on the roof deck, and then this was just going to be porch. So initially they were going to deck all of that underneath the framing of this. Now what we ended up doing was putting the sheathing under there, as well as coming back over top, because I didn't want to just leave this gable opening right here. We ended up adding the zip system over top of this whole porch. As you can see, the zip is suspended up over there. That way up here we could get a tight area. The reason why I wanted to do this was to ensure, number one, that I had a good seal underneath the porch. I didn't want to create a void there and then have to make some kind of funny spot to have to air seal. We ended up running zip along the roof line before we attached top of that porch. Hopefully that makes sense. You guys are following along with that. This is one of these flanges I was talking about that we created. As the porch ties in here, you can see the same thing at the very top where the purlin joins the wall. And these are going straight through some blocking on the other side. So that's how we're able to attach that going all the way up. There is some insets here. So it got kind of tricky here the way we were doing the porches and the way we had to attach the soffit. It will run flush up under that zip where it changes to go straight under. That way it looks seamless when it's all finished. It'll make a lot more sense in the end, but like I said, it's been a little bit fun trying to create these minimal attachments. It's not necessarily any less attachments than we normally do. It's just being strategic and make sure that we don't have a bunch of funny things that we have to seal around. Okay, now as we come in, notice these huge doors right here. Now, anybody I think would be excited to have a slider like this, just one, but there's like 5 in this room that open in the whole great room, which is pretty awesome, plus over the kitchen area. And it's really nice today because we can easily open this up and get a huge breeze through here. Remember, we're building for air tightness, so everything's pretty closed down right now, and it's hard to get the breeze, but you just, here it's really nice. You can just open up the doors. And I love how you can just easily glide these bad boys over and voila, look at all the extra space we've got to come in and outside. This is gonna be super nice for the clients. And Brandon was strategic too about how these open and close. So you can choose, I think, which side you want them to open. Now, as far as things that are different in here from the last time you guys looked, other than the windows and doors, a lot hasn't changed in here. We have had the plumbers in here just the other day, and they were doing a lot of their installation. You can see we've got piping and stuff that's coming up and around. We've got a lot of cavity space, and because we're getting ready for performance tests, they're going to be closing off some of these doors. But I wanted to show you a couple things that we're doing in here. Right now we're doing our waterproofing for our showers, as you can see, and we have a linear drain going in here on this shower, but we've got valve control here on this side. We've got a soapbox there in the middle with the shower head on that side, and no curbless transition there. So it's a full shower with a linear drain, which those are always really cool. And this is what I was trying to show you guys. We have doors, these sliders, in every room. So every room has a private slider. Now, the great thing about this is this serves not only as a door, but it serves as window space that goes all the way up and down to the floor. It looks just like windows because it's got the grids in it. It's really, I think, a beautiful design. I think it works well with what the client was looking to accomplish here. And as you could imagine, you're not losing wall space from windows and stuff like that because you got the door that you can use as well as a window for that. Pretty neat, guys, and that's like that in every room. Now, since the last time we were over here, we have poured concrete, and right now we're doing some mixing and stuff in here, but you can see all the concrete in here has been poured, but you can see the progress here. We've got water heater that's going to go right here on this portion. You can see some of the plumbing that's coming in from up here. So you've got a shower drain, we've got a toilet drain that's going in there. And then on this side, I love how this turned out. You're not really, we've got a basement underneath us. So, and it just feels pretty normal, like your typical garage. But as you go down, it's completely different. Another thing that we've done is we sealed off, as you can see, Brandon's got all this sealed off on the side. This was all open last time we were here to the attic area. What we're preparing ourselves for is we're probably going to end up adding insulation underneath here for that upstairs area. Now, we do have exterior insulation that wraps all the way around the garage, but this has kind of got its own insulated area right here. You know, keeping everything contained in this room, because you might have gas can, lawnmowers, things like that. You're not wanting all that to seep up into some of these living areas. So we sealed all this off. It's going to be part of our air test because of the connection between the basement and this area. Okay, well, that's pretty much going to conclude the update for today on this build. We are definitely ecstatic about the test results here from the home energy audit guys that came out here. What we're leaving here with is that zip system, we got it zipped up. This is a 0.60. Can it be better? It could actually improve a little more because we found some spots that we could actually come back and do a little bit better job. We're really excited though because a 0.60 and then the code is like 3.0. I think achieving this with just the zip system, that means that potentially by the time we get all of our sheetrock, insulation, all that stuff done, that we could be a zero energy. So it really just depends on what improvements we can make. Ultimately, let me say this, once you get to this level of airtightness, there's really, like making it more airtight is not maybe the goal. It's more thinking about, okay, we're already so airtight, we need to consider what we're gonna use for our air conditioning systems, make sure we have variable speeds, dehumidifiers, ERVs perhaps on this particular build. It may come into play. I mean, really trying to go any further or spend a lot more money to try to get it down to some lower score is going to be maybe good money spent for bad at this point. The good news is we got a good airtight structure with the zip system. If you are one of our existing clients and this is something that you're wanting to do to see what it would cost to add the additional zip system on the top, then just get with the superintendent, Brandon, or myself. So we appreciate you guys following along. For more updates to come on this build, we got a lot coming up. I'm Josh Helm, wishing you all the best. Thanks for watching. Texas Best.